The National Electrical Code, or NEC, does not specifically mandate the installation of a dropout contactor on a Bridgeport mill or similar machinery. However, it is crucial to understand the NEC broader requirements regarding motor protection. The NEC mandates that all motors must be protected against overloads by an approved means. This protection can be achieved through devices like circuit breakers or fuses carefully selected to match the motor's characteristics and operating conditions. Overload protection safeguards the motor and its associated circuits from excessive current draw that can lead to overheating and potential damage. Secondly, the NEC requires that all motors be protected against short circuits by an approved means. Similar to overload protection, short circuit protection is typically provided by circuit breakers or fuses. These devices are designed to quickly interrupt the flow of electricity in the event of a short circuit, preventing severe damage to the motor and the electrical system. In most common scenarios, a dropout contactor is not strictly required to meet the core requirements outlined in the NEC for motor protection. The standard overload and short circuit protection measures are often sufficient to ensure safe and compliant operation. However, there are specific circumstances where the installation of a dropout contactor may become necessary to meet the NEC intent and ensure safety. One such scenario is when the motor is located in a hazardous location. Hazardous locations, as defined by the NEC, are areas where there is an increased risk of fire or explosion due to the presence of flammable gases, vapors, liquids, or combustible dusts. In these environments, a dropout contactor can provide an additional layer of safety by automatically disconnecting the motor from the power supply in the event of a fault or emergency, minimizing the risk of ignition. Another situation where a dropout contactor may be required is when the motor is used in a system that requires frequent starting and stopping. In applications involving repetitive motor operation, a dropout contactor can help to reduce stress on the motor and its control circuitry, extending the lifespan and improving overall system reliability. Moreover, a dropout contactor can provide a means of quickly and safely de-energizing the motor in case of an emergency or malfunction. The decision of whether or not to install a dropout contactor depends on a careful assessment of the specific application, the operating environment, and the relevant electrical codes and standards. It's always best to consult with a qualified electrician to determine the most appropriate and compliant solution for each individual case. When evaluating the need for a dropout contactor, several factors should be taken into consideration. Firstly, the motor's horsepower rating and voltage should be considered. Larger motors typically require more robust protection measures, potentially including a dropout contactor. Secondly, the type of load that the motor is driving is a factor. If the motor is driving a critical piece of equipment or a process that could pose a safety risk if it malfunctions, a dropout contactor may be warranted. Thirdly, the frequency of motor starting and stopping is another aspect to consider. As mentioned earlier, frequent starts and stops can put extra stress on the motor and its control components, making a dropout contactor a beneficial addition. Fourthly, the presence of any hazardous conditions, such as flammable materials or explosive atmospheres, should be carefully evaluated. In these situations, a dropout contactor can significantly enhance safety. Lastly, the specific requirements of the local electrical codes and standards must be followed. Local regulations may have additional requirements beyond the NEC, mandating the use of dropout contactors in certain applications. It is important to remember that the NEC is a comprehensive set of guidelines, but it is not a substitute for sound engineering judgment and professional expertise. A qualified electrician can assess the unique characteristics of each installation and recommend the most appropriate solutions to ensure safety and compliance. In addition to providing overload and short-circuit protection, a dropout contactor can offer other benefits. Firstly, it can provide a means of remote control, allowing the motor to be started and stopped from a distant location. Secondly, it can be integrated into an emergency stop system, enabling the motor to be quickly de-energized in case of an emergency. Thirdly, it can provide a visual indication of the motor's operating status, making it easier to monitor and troubleshoot the system. When selecting a dropout contactor, it is important to choose a device that is properly rated for the motor's voltage, current, and horsepower. The contactor's coil voltage must also match the available control voltage. Furthermore, the contactors should be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL, to ensure that it meets safety standards. The installation of a drop-out contactor should always be performed by a qualified electrician in accordance with the NEC and all applicable local codes and regulations. Proper wiring techniques, grounding methods, and overcurrent protection must be employed to ensure safe and reliable operation. It is also important to periodically inspect and test the drop-out contactor to verify that it is functioning correctly. Regular maintenance can help to prevent unexpected failures and ensure that the motor is adequately protected. The NEC provides specific guidelines for motor protection in Article 430. This article covers a wide range of topics, including overload protection, short-circuit protection, motor control circuits, and motor disconnecting means. It is essential for electricians and engineers to be familiar with the requirements of Article 430 to ensure that motors are installed and protected in accordance with the NEC. In addition to Article 430, the NEC also contains specific requirements for hazardous locations in Articles 500 through 516. These articles address the special considerations that must be taken into account when installing electrical equipment in areas where there is a risk of fire or explosion. When working in hazardous locations, it is crucial to follow all applicable codes and standards to minimize the potential for accidents. The NEC is updated every 3 years to reflect changes in technology and industry practices. It is important for electricians and engineers to stay up to date with the latest edition of the NEC to ensure that their work is compliant with current regulations. Continuing education courses and professional development programs can help to keep professionals informed of the latest changes in the NEC. In summary, while the NEC does not explicitly require the installation of a drop-out contactor on a Bridgeport mill or similar machinery in all cases, it does mandate comprehensive motor protection. This protection encompasses overload and short-circuit protection, typically achieved through circuit breakers or fuses. However, in specific situations, such as hazardous locations or systems with frequent motor starts and stops, a drop-out contactor may be necessary to meet the NEC intent and ensure safety. Consulting with a qualified electrician is always the best course of action to determine the most appropriate and compliant solution for each unique application, taking into account factors such as motor size, load type, operating frequency, and the presence of any hazardous conditions. Adherence to the NEC and local codes is paramount to ensure the safe and reliable operation of electrical equipment.